Okay, next what we're going to do with the arithmetic sequence is we're going to talk about the sum of the first n terms, otherwise known as the nth partial sum. Or basically what we're going to do is we're going to add up the first n terms. So of course we've got our sequence here, 0, 2, 4, 6, 8 as before. If we were to add them up, we can see that we would get, a 0 and a 2. 2 and 8 is 10, 4 and 6. It should equal 20. So that's what we're going to be doing here for a second. The sum of the first n terms, or the nth partial sum, is S sub n is going to equal, or the sum of the first n terms equals n, the number of terms, divided by 2, times a sub 1, or the first term, plus a sub n, or the last term. So the first example we're going to do here is we're going to find S sub 5 when a sub 1 equals 0 and a sub 5 equals 8. So we've been given all the information we need. The sum of the first 5 digits is going to equal 5 divided by 2, or the number n divided by 2, times our first term 0 plus our last term 8. We can see that we'd have 5 halves times 8. 8 plus 0 is 8. We would think of that as 8 over 1, so that we could do a little cross reducing here with the 2 and the 8. And lo and behold, there we get our answer of 5 times 4 over 1, or in other words, 20, the sum of the first 5 terms in this case. Now, it's possible sometimes we're going to ask you to do the same thing, find S sub 5 when you know the first term, a sub 1 equals 0, but we don't tell you the last term. We tell you the common difference instead is 2. So in this case, we have to go back to what we had previously learned, and we have to find the nth term, or in this case, since we're looking for the fifth term, a sub 5. So we know that's the first term, a sub 1, plus n, 5, minus 1, times the common difference of 2. So the 0 doesn't really do anything for us. 5 minus 1 gives us 4 times 2, which gives us the last term of 8, which we had been given up here before. We would do the same problem to get to that same answer. So those are the first two examples here. Really basically the same idea, but two different ways to look at the same example. Now the next one I want to take a look at here, a little different. We're going to do summation, and we're going to use the nth partial sum to solve a summation problem. So we're going to look at the summation when I equals 1 to 5 for the equation 2i minus 2. Now, if we'd multiplied this out and added it all up as a summation, we'd have to write this out 5 different times. Whoa, what's going on here? So sorry about that. We'd have to write this out 5 different ways, and it would look like this. It would be 2 times 1 minus 2 plus 2 times 2 minus 2 plus 2 times 3 minus 2 plus 2 times 4 minus 2 plus 2 times 5 minus 2. You see, that just takes a lot. That's a lot more work, especially if we don't have to do that. I keep hitting the button on my pen. I'm so sorry. Now, let's see how we can do this with the summation instead. What we can do with the summation instead is we can realize all we need to know is the first term, the nth term, which in this case, if we're going from 1 to 5, there are 5 terms, so we're looking for the fifth term, and how many terms there are, what n is, which would equal this guy minus 1 plus 1, which from 1 to 5 is going to be 5. So we know that's 5 in this case. We can come up here and we can simply plug in the first 1 into here to find the first term. So we're going to say 2 times 1 minus 2. 2 times 1 is 2. 2 minus 2 is 0. There's our first term. We can find the fifth term by doing the same thing. 2 times 5 minus 2. That gives us 10 minus 2, which is 8. So again, you can see I've created the same problem. Our first term is 0 right here. Our fifth term is 8. And we have 5 terms. So we get the exact same answer here for our summation, either doing it the long summation way or doing the nth partial sum. We now know that that equals 20. I hope this helps out, folks. You have some homework problems to do with this, and enjoy. I will talk to you in the next video conference. Bye-bye.